Every smartphone in the world runs on one of two operating systems. You're probably holding one right now. But here's the thing. Most people think the difference between iOS and Android is just about which logo you prefer, or maybe which one has the better camera. That's like saying the difference between a sports car and a pickup truck is just the color. Under the hood, these two systems are fundamentally different in ways that affect everything from how your apps run, to how long your battery lasts, to how secure your data really is. Today, we're going to crack open both operating systems and see what's actually going on inside. Let's start at the absolute bottom. The very core of any operating system is something called a kernel. Think of it as the system's brainstem, the most basic layer that talks directly to the hardware. Android uses a modified version of the Linux kernel. Yes, the same Linux that runs on most of the world's servers. This is a monolithic kernel, which means it handles everything from memory management to device drivers, all in one giant chunk of code. It's powerful, it's incredibly flexible, and because it's open source, manufacturers can customize it to run on anything from a smartwatch to a refrigerator. I/O, on the other hand, uses the XNU kernel. XNU stands for X is not Unix, and it's based on a hybrid of the Mock microkernel and components from BSD Unix. This hybrid approach keeps the core of the kernel small and modular, while still giving it the performance it needs for demanding tasks. What does this actually mean for you? Well, the Linux kernel in Android is designed for maximum flexibility. It can run on thousands of different hardware configurations, which is why you can get Android phones that cost $100 or $1,500. But that flexibility comes with trade-offs. The XNU kernel in I/O is designed for exactly one thing: running Apple hardware. This tight integration is why iPhones often feel more responsive, even with less RAM and slower processors on paper. Now, let's talk about how apps work. This is where things get really interesting. When you open an app on Android, that app is running inside a virtual machine called Android Runtime, or ART. Before that, it was Dalvik. What's a virtual machine? Imagine you have a translator who takes an app's instructions and converts them into something the phone's processor can understand, but it does this translation on the fly every single time you run the app. This just-in-time approach means Android apps are incredibly portable. Write an app once and it can run on pretty much any Android device without modification. But there's a cost. That translation layer takes processing power and battery life. It's like having someone translate a conversation for you in real time, instead of just speaking the language yourself. I/O does things differently. When developers build iOS apps, they compile them directly into machine code, the native language of the iPhone's processor. When you tap that icon, the app just runs. No translator, no middleman, no virtual machine. This means I/O apps can start faster, use less battery, and generally feel more responsive. But it also means those apps are tied specifically to Apple's hardware. You can't just run an iPhone app on an iPad without the developer making changes, because the code is speaking directly to specific processor instructions. This brings us to one of the most misunderstood differences between iOS and Android: how they handle multiple apps running at the same time. On Android, apps can run in the background pretty much as they please. They can check for new messages, update your location, sync photos, and generally do whatever they need to do. This is true multitasking, and it's great because your apps always feel alive and responsive. But there's a downside. Apps running in the background consume battery and CPU cycles. Android's solution is sophisticated memory management that automatically kills processes when it needs more resources. But this can sometimes lead to apps being killed too aggressively, forcing them to restart when you switch back. iOS takes a completely different approach. It uses what's called a pseudo background system. When you switch away from an app on iOS, that app is essentially suspended. It's frozen in place, consuming almost no resources. The system can wake it up periodically to handle things like push notifications, but for the most part, background apps are in a state of suspended animation. This is why iPhones have historically been able to do more with less RAM. An iPhone with 4 GB of RAM often outperforms Android phones with 12 GB because it's not wasting memory keeping apps alive that you're not even looking at. But it also means apps have to rebuild their state when you switch back, which can be slower for apps that were doing intensive work. Now, let's talk about security, because this is where the philosophical differences between Apple and Google really shine through. iOS operates on what security experts call the walled garden approach. Every app goes through a strict review process before it can appear in the App Store. Apple examines the code, checks for security vulnerabilities, and makes sure developers are following their guidelines. This review process is far from perfect, but it does catch a lot of malicious software before it ever reaches your phone. More importantly, iOS uses something called a sandbox for every app. Each app lives in its own isolated container. It can't access other apps' data. It has to ask permission for everything: your photos, your location, your contacts. And because iOS controls the hardware, it can enforce these restrictions at the deepest levels. Android takes a more open approach. You can install apps from anywhere: the Google Play Store, third-party stores, or directly from a website. This is a feature for power users and developers, but it's also a security risk. The Play Store does scan apps for malware, but it's a less rigorous process than Apple's manual review. Android's permission system is also fundamentally different. Rather than asking for permission when you need it, many Android apps ask for all their permissions up front when you install them. This has gotten better in recent versions with more granular permission controls, but the underlying model is still different. The technical term here is least privilege. iOS apps start with 0 permissions and have to ask for each one. Android apps often start with broad permissions and can do more out of the box. Here's another crucial difference: fragmentation. It's the dirty little secret of the Android ecosystem.